Good morning, class. We are looking at inverse trig function, part 2. We're going to continue on the thoughts. So we've already looked at graphs of functions, trigonometric functions, phase shift. We've already looked at inverse functions, and we're going to continue with the concept. We're going to find the exact value of expressions involving inverse functions. We're going to define inverse secant, cosecant, and cotangent. We also use a calculator to find their inverse functions and write a trigonometric expression as an algebraic expression. So reminding everybody of what we have seen as far as fundamental identities: unit circle, x squared plus y squared equals 1. And as a result of that, when a pair defined as x and y becomes cosine and sine, when a unit circle becomes a general circle, then, for example, sine which was y becomes y over r, and cosine which was x becomes x over r. The rest of them are easy to figure out. So a periodic function, every function, trigonometric function, is periodic with a period of 2 pi, except tangent, and with that goes cotangent, which is pi. So t is 2 pi for all of them, except tangent and cotangent. T is pi. Every function, trigonometric function, is an odd function except cosine, which is an even function, and with that goes secant. Fundamental identities, extremely important: Pythagorean identities, quotient identities, and reciprocal identities. As far as graphs of sine and cosine, we discussed there are 4 arcs. You basically cut the period of 2 pi into 4 pieces. This is a basic sine function. So this is 1 arc, 2, 3, 4. And you do the same thing for cosine, 1 arc, 2, 3, 4. And the relationship is that every sine can be represented by cosine or vice versa. Sine is cosine of x minus pi over 2. And if you happen to have a case y equals a sine omega x or a cosine omega x, the period becomes 2 pi over omega, and the amplitude is the absolute value of a. The trigonometric functions, none of them is one-to-one. All of them are fail the horizontal line test. So what do we do when we do the restriction? And the restriction is that for sine, we restrict it from negative pi over 2 to pi over 2. The same thing for tangent. In the case of a sine, the endpoints are included. In the case of a tangent, the endpoints are not included. Cosine, we restricted from 0 to pi. Now all 3 are 1-to-1. They have an inverse function, and we write the definition of an inverse function as well as their graphs. So that's the synopsis of what we have done. Let's add to this by looking at more trigonometric, inverse trigonometric functions. We want to find the exact value of this expression. So the very first thing is, when we look at sine tan inverse of 1/2, we should recognize this is an angle on arc. So let's call this alpha, beta, gamma, theta, whatever you like. So if we call this theta, by definition, it means tan of theta is 1/2. And we know that because it's an inverse function, tangent is between negative and positive pi over 2. So this is sine of theta. This is sine of theta. And tangent is equal to 1/2. Because tangent is positive, we're talking about inverse tangent, and we go from negative pi over 2 to pi over 2, this must be the first quadrant, which means sine is positive. We can find it a couple of different ways. So quickly, tangent is 1 over 2, which is y over x. And so y is 1, x is a 2. We can calculate the r. So if we have those, as you know, x squared plus y squared is r squared. And in this case, 2 squared plus 1 squared, and that's how we get 5, and this is square root of 5. So having the pair x comma y, we can find the r. Now sine theta is y over r, and the answer is 1 over square root of 5 let's fix this, which is square root of 5 over 5. Square root of 5 over 5. Because all you have to do, multiply by square root of 5 over square root of 5. And we're done. But if we were to do this by identity, because you really have to know both, the relationship between tangent and sine, if we use the Pythagorean identity that 1 plus tan squared or tan squared plus 1 is a secant squared, that will give us secant and therefore cosine, and sine squared plus cosine squared is 1. We can get to the answer. In this case, it's a little bit longer, but just a quick process. Tan is 1/2. So plug it in. You get 1/4. So secant squared is 5 over 4. And secant is the square root of that, which is square root of 5 over 2. Square root of 5 over 2. Cosine becomes the reciprocal of that. And we know sine squared plus cosine squared is 1. Or you may use the fact that tangent is sine over cosine. Tangent is sine over cosine. So sine is the product of these two. Tangent is 1/2. Cosine is 2 over square root of 5. The 2's cancel out. You get 1 over square root of 5, which is square root of 5 over 5. So we get to the same answer with a different process. And it so happened in this example, this takes longer. So you really have to be aware of both methodologies and then use the one that works the best. All right, let's look at this example. We are interested in cosine of sine inverse of negative 1/3. If we set this equal to theta, that means if we set this equal to theta, that means sine theta is negative 1/3. So we are looking to find cosine theta. So we are looking to find cosine theta given sine theta. And we know that sine goes from negative pi over 2 to pi over 2. If sine is negative, then it must be in the fourth quadrant. So negative must be in the fourth quadrant. In the fourth quadrant, cosine is positive. So if we want to stick with the circle, let's write sine theta is equal to negative 1/3. It's equal to y over r, where y is negative 1 and r equals 3. Why is that the case? First of all, r is always positive. Secondly, we are in the fourth quadrant. Therefore, y becomes negative. So if you have x squared plus y squared equals r squared, you can find this to be 2 square root of 2. So all you have to do, replace the y with negative 1 squared. If you do that, that means 1. That means x squared is 8. X is plus minus square root of 8, which is plus minus 2 square root of 2. In the first and fourth quadrant, x is positive. Cosine is x over r. And it's 2 square root of 2 over 3. This is the synopsis of what you have here. Okay, if you draw this. That's the same triangle. We made it a tad large. Now, this could have been easier using the identity of sine squared plus cosine squared equals 1. Sine theta is negative 1/3, plug it in, solve for cosine. And we know it's positive because it's in the fourth quadrant. So in this example, cosine squared, of course, becomes what? 8 over 9 if you subtract it from 1. And the square root of that is 2 square root of 2 over 3. I hope you realize it's easier with the identity in this example. Is that the case always? It depends. All right, what about this example? Again, we let this one be an angle, alpha, beta, gamma, theta. So what does it mean? We are looking for tan of theta. That's what we are looking for. So we are going to write cosine theta is negative 1/3, and from cosine we want to go to tangent. And before we do that, we notice that in this case, theta is between 0 and pi, because remember, in the case of a cosine, 0 to pi. And if cosine is negative from 0 to pi, must be in the second quadrant. So must be in the second quadrant. Cosine is negative. Because it's inverse, we have restricted it from 0 to pi. That means first and second quadrant. Negative means the second quadrant. And so you can write it as x over r. So you have the value of x and r. If we write it as x over r, again, r is always positive, everybody. In the second quadrant, x is negative. And so what is the value of y? You can calculate it again, you get 2 square root of 2. If you look at this one, this is the location, negative 1, y, here's r, and we can show it this way. And when we write down, let's just quickly write down, if we write x squared plus y squared equals r squared, which is 9, y squared becomes 8, and y becomes square root of 8, which is 2 square root of 2. So we have x, y, and r, and we know tangent is y over x, y over x. Tangent is y over x, so we just plug into y over x, 2 square root of 2 over negative 1, and the answer is negative 2 square root of 2. So that's a process that we go through. If we look at others, such as secant, cosecant, and cotangent, again, they are not one-to-one. You have to do the restriction. And the way the restriction works, secant is 1 over cosine, so we do the same thing as cosine between 0 and pi. Needless to say, it can't be pi over 2. Cosecant, let me just write it this way, it will help. So this is 1 over cosine. So think of cosine for the restriction. This one is 1 over sine. So think about sine for the restriction. Cotangent is not, although it's 1 over tangent, but it's not going to follow that. The reason it follows 0 to pi because of the graph. If you go to basic graph, we go from 0 to pi. That's why. Again, that has got to do with the graph, not the fact that it's the reciprocal of a tangent. That's not the reciprocal. So with that being the case, what is cosecant inverse of 2? Well, we know cosecant is 1 over sine. Okay, so we are going to write cosecant theta is 2, therefore sine theta is 1/2. And this is a common arc. You know theta equals pi over 6 or 30 degrees. And that's the answer for cosecant as well. Because it was a common arc, we don't have to use a calculator. Let's look at a few that they need using a calculator, and we are going to approximate it accordingly, however many decimals that they say. You always use many more decimals unless they ask. Since they ask for 2, we're going to go with 2. We're going to start with the first one. We want secant inverse of 3. So in order to get that, that means we are looking for an angle whose side, that means secant theta is 3. That's the concept. But we want to use a calculator, and we know that secant is the reciprocal of cosine, so we're going to say secant inverse 3 is the same as cosine inverse 1/3. And now if we use a calculator, cosine inverse of 1/3 gives us this answer. Now we want 2 decimals. This is the second one. Next to it is 0, so it remains unchanged. Using a calculator. It must be in radian mode. Part B, we want cosecant inverse of -4 because of the relationship with sine. It's sine inverse of its reciprocal -1/4. So if we use sine inverse of -1/4, and again we want 2 decimals, 1, 2. Next to it is number 2, so it remains as -0.25. -0.25. Normally, we are interested in more decimals. Needless to say, you could go to a circle and find the answer. But let's continue with the thoughts. If we are looking at cotangent inverse of 1/2, we can say Cotangent is x over y. And remember, for cotangent, we are going to go from 0 to pi. Cotangent, we're going to go from 0 to pi. So how do we approach that? I want you to pay attention to this one particularly. So 0 to pi. So if we go with this, from 0 to pi, and cotangent is positive, therefore we are in the first quadrant. Right? So x and y, it's 1 and 2, and r would be 1 squared plus 2 squared makes it 5. So if this has coordinates 1 and 2, square this one, you get 1, square this one, you get 4, add them up, you get 5. So this must be square root of 5. So x squared plus y squared equals 5. Now you can find cosine inverse of 1 over square root of 5 if you want to go by cosine. And I want to discuss that when it comes to cotangent, why you want to do that, because the calculator does not have an inverse normally for secant, cosecant, and cotangent. So you can go to cosine and you get this answer. However, because it's positive, you can also go with tan inverse of 2. Tan inverse of 2. And we want 2 decimals, so this is the number we want. Next to it is 7. We take it up to 1. That's how we get to 1.1. So I want to repeat this. Cotan inverse, we don't have it on a calculator. So we stick with cosine inverse or tan inverse. If it's positive, you can go with tan inverse. It's faster and easier. If it's negative, it will not give you the correct answer. So when it's negative, I want to discuss this one. We know that cotangent is between 0 and pi, but tangent is between negative pi over 2 and pi over 2. So if you said the reciprocal is negative 1/2 and you go with tangent, it gives you a wrong answer. That's why they stick with cosine, because cosine also goes from 0 to pi. So with that being the case, if you want to find the cosine, first understand cotangent is x over y. And this must be in the second quadrant. In the second quadrant, x is negative, y is positive. So you write negative 2 as negative 2 over positive 1. And it gives you this pair. And again, r becomes 5. Cosine is x over r, so negative 2 over square root of 5. And if you use that, the calculator will give you the correct answer of 2.68. However, if you use tangent, this is really for negative numbers. You have to add a pi. So if you use tangent, gives you this number. Are you with me? Tan inverse of negative 1/2 is negative 0.4636, continues indefinitely. We need to add a pi. And when we add a pi, remember a pi is 3.14159. It gives you the same answer. Remember, you go with the second one. The number to the right of it is 7, and you take it up to 8. So I hope everybody understands that. So quickly, if they're all positive, you have nothing to worry about. But when cotangent is negative, it's better to go find the cosine and find the inverse of that, or you can stick with the tangent and then add a pi. Because for a negative value, tangent will take you to the fourth quadrant. Remember, tangent is from negative pi over 2. Tangent goes from negative pi over 2 to pi over 2. So you want to be careful with it. We want to come up with the expression sine of tan inverse of u. There are different methods to approach that. So if we want to stick with identities, number one, notice this, if you set it equal to x, y, z, theta, it means tan theta is u, and it means you're looking for sine theta. That's the meaning of this expression. Again, let tan inverse of u be anything, such as theta. By definition of an inverse function means tan theta is u. Therefore, you're looking for sine theta. One way to do that, you can use one of the Pythagorean identities. 1 plus cotangent squared is cosecant squared. The reason we are using this because cosecant is 1 over sine. So if we find cosecant, the reciprocal is the answer. And if I want to use cotangent, if this is u, then cotangent is 1 over u. Okay, so 1 over u, and this is 1 over sine squared. Or you can find cosecant and then find the reciprocal. So when you take a common denominator here, you get 1 plus tan squared over tan squared. So if 1 over sine squared is equal to that, what is sine squared? The reciprocal of this is sine squared. Again, you could finish the job and then just find the reciprocal. You don't have to go through this process. What is tan? Is u, replace it. So what is sine? It is the square root of that. And you keep the positive because sine and tangent have the same sign. How do we know that? Both of them go from negative power to power 2. The difference is tangent doesn't have the endpoints sine does, but they go from, they stick with the same quadrant. Let's look at a couple more examples. We are interested in finding tan of sine inverse. And we know if we set this equal to theta, that means sine theta must be u. We are looking for tan theta. One easy way is to use the identity that tangent is sine over cosine. And we know cosine is the square root of 1 minus sine squared. It's plus minus, but they have the same sign. We don't have to use positive or negative, just this. And if you replace the sign with u, we are done. We want tangent of secant inverse of u. So we look at this one, means if we set this equal to theta, then secant theta is u. In other words, secant is given, find tangent. That's really the bottom line. So secant theta is u, and we know the restriction is that secant is just like cosine. It goes from 0 to pi, and power 2 is not included. So given secant equals u, can you find tangent? And we have this Pythagorean identity of 1 plus tan squared equals secant squared. And that means tan squared is secant squared minus 1. Replace the secant with u. You get u squared minus 1. And tangent is the square root of that. We're interested in finding cosine of sine inverse of u. We let sine inverse be theta. That means sine theta is u. Look for cosine. We know sine squared plus cosine squared is 1. That means this and cosine squared is 1 minus u squared. Take a root and you're done. I'll show you these pages. The meaning of secant inverse, which was discussed. Secant is 1 over cosine, so we stick with the same restriction as cosine. Of course, y can't be pi over 2 because of the VA or vertical asymptotes. Cosecant is 1 over sine. That's why we use the same restriction. Of course, y can't be 0 because of the VA or vertical asymptotes. Cotangent, we know it goes from 0 to pi for a complete cycle, and that's why we use that as the restriction to make it a 1-to-1 and come up with the inverse. And that's it.